Okay, the word I was looking for was synthesize. That's what I was trying to think of. And this is how to synthesize the call. Now what you want to do is something like this. You want to be able to call super and whatever the method is from some sort of access method. Now obviously the return type and any parameters are going to be matched up between the access method and the method you're trying to call. And I assume as well the any exception handling has got to be throws, clause, and so on. It's got to match up to. I mean, that's all fairly obvious. But the thing is, you want to do this not from something like that, not from that, but from a static method. So it's got to be something like that. Now, if you write the access method as an instance method like that, of course, it means that some hidden parameter referring to the current object is passed in. Okay, that's implicit in all instance methods. And so passing that to the static version should in fact supply it with enough information to be able to do the call. Okay, now if you take a look at some of this code that gets generated, here we've got or out extends A, and it's just got a method M there that we're trying to go for. And this inner class in1 here extends A, and well, that's not important because what it's doing here is out.super.m. So it's going to try and access the superclass version from out. Putting that in just complicates the issue. It's not important. So if we take a look at a couple of the code that gets generated from various options. So if we take a look at this, if we write this in static void access 1, passing in an instance of out and using that to call the superclass version M, and we look at this, which is an instance method, and calling super from that. If we look at the code that those two methods generate, access 1 and access 2, you can see that access 1 is generates that, which is simply an invoke virtual, and access 2, which is what we're trying to head for, uses invoke special. So what we want is basically the invoke special there, and in fact that is what the code in fact generates. When you look at the actual access method as the actual one that gets generated, it calls invoke special. So it looks just like that, but it also looks a bit like that too, because the parameter out is passed in, because it's static, of course. So there's enough information there to do it. You can't actually write it in Java. The equivalent thing in here in Java would be have the word static in front of that, I suppose. But of course that won't compile. But that's effectively what it's doing. Compiler again can generate this sort of code, but you can't write it in Java. I haven't, by the way, put the constructor code in for out here because that just complicates the issue. There's no point in doing it. I'm just saving space, otherwise it won't fit in. The numbering of access methods which arise as a result of super is the same as it would be if it had been an ordinary access method that was accessing some private field or a private method, except that 1 is added, making the number odd rather than even. And the code generation phase of the compiler then uses the fact that the number's odd to generate invoke special rather than invoke virtual for any method call, allegedly. Now that's what it says in the Java reference compiler. That's what it says it does, but I'm not sure it's actually necessary to do that, and other compilers may differ. But that's what it does anyway. Now, although the super access method has a number which is 1 greater, we can never end up with two identical access methods doing the same thing, that is, with different numbers. And the reason for that is that ordinary access methods are only needed for accessing private methods or private fields. And class.super will never allow access to fields or methods which are private. Okay, so there's never going to be a conflict between the two. Not that I think if they had two the same it would be that much of a conflict, but it's just more an observation than anything else.